Hello everyone, we are Team 2 and our product is a data importer and validation application. My name is Alexander Reed. This is Jared Medeiros, he's the Scrum Master, and our developers Ian Whalehan and Megan Denny. Our client is Joe Vitello of South Coast Health. So, South Coast Health is a company that needs to import various insurance records from insurers every month. The issue that they run into is the structure of these insurance records changes frequently, and the insurance companies often don't provide them that change in structure. Now, in order to solve this problem, our program is going to first need to be able to import the data from a file. Second, it needs to be able to generate a specification by iterating through that data file. Then it needs to offer the user a variety of different applications in order for them to validate and find errors within the file. So, at South Coast Health, they use SQL servers in order to be able to save and use different files within different programs. So, our program is able to implement SQL servers to be able to save and load specification files, message logs, and translational tables. That way, our program is able to work with existing records at South Coast Health and can provide the records that we generate to other applications. Our application uses a structure called a MDI, or Multiple Document Interface, where there is one parent container, and then every document we open up within the program will be represented as a child container. The parent container will have all the functions on the main toolbar, and then these subforms will also have relevant functions on their own toolbars. So the first thing we need to do once we've started the program is import a file record for us to use. The program will automatically determine a delimiter by going through the first few lines, and then use that to take all of the headers and file information and place them into a table. Each row entry of one of these records is an entry into the file. So if the file that we're dealing with is a medical claims file, then each row entry would be an instance of the medical claim. So if I went to the doctor and got a flu shot, that was covered by my insurer, it would be a row entry into one of these data records that would contain my name, my address, my information, and the name of the procedure. Once we've successfully imported the data files, we need to generate a specification. Specification files will contain information about every column of a data file as a row entry. Each row will tell us information about whether the column is meant to be unique to each cell, whether the column is allowed to have empty cells in it, and the minimum maximum length of the information in the cell, and what data type it's meant to be. Our program will generate this specification automatically by iterating through all of the columns of the data file to find the minimum cast that we can say for each of these, so that it will always return no errors with the specification that we generate. The translation table is another thing that we need to be able to create with this program. Translation table takes a series of codes in a program and gives the functionality to be able to translate. So zip codes would be able to be translated by South Coast Health to the areas, or state IDs to the areas. For my example, when I got my flu shot, the code that they would have used is ICD-10, which would then be translated through the translation table to flu shot. So for our development tools, we used Visual Studio with C# for development. We used WinForms for our user interface within that. For communication, we used Trello and Discord mostly. Trello was for texts. We took a Scrum approach and we held stand-up meetings at least 3 times a week, as well as the regular Scrum meetings and everything. And we use SQL Server 2014 for our SQL stuff. And I'm going to now hand it over to Jared to do the demo.
Thank you, Alex. So the first thing that opens up when our application starts is a blank window with a toolbar along the top. This toolbar along the top has all the functionality for our application. So we're going to use, for example, that Alex works at South Coast, and he's just received a file from the insurance company. The first thing he's going to want to do with this file is load that file into the application. So he can select the Load Data button on the top of the toolbar, and it will bring up a new window. This new window is going to be used to preview the information for the file that we select. So when we select Load Data on this new form, it brings up a file browser. And for this example, medical claims is the file that Alex received. So from when we select the medical claims file, it's going to populate all of the information in the preview form. The first thing that you see for the preview is the predicted delimiter, which in this case, the program detected to be a bar, which I know from knowledge of the application, bar is correct. So we're going to stick with that, but if it was incorrect, I can change that. The next two fields are the number of rows and number of columns in this file, which is self-explanatory. It's just almost like an Excel file, how many rows and columns are there. The last thing would be the predicted headers or the names of the headers that are in the file, which just give the preview to South Coast of what kind of information the file is going to contain. In case there's any incorrect reporting that might happen, they can detect it beforehand. So when we go ahead and select load the file into the application, it's going to bring up another new window, this time almost like an Excel sheet again, where it's a table with all the file's contents. As you've seen with the predicted headers, it has all the headers along the top that were there before. Those headers are going to be useful for the specification, because when we generate the specification, that's going to show every single header in that column into a specification row. So the specification rows match up with data file columns. So a lot of times these specifications that we generate aren't going to be accurate when South Coast receives the file. But to show that this specification is accurate because it was generated from the data file, we're going to create a message log based on the data file and the specification we created. The message log is going to check for discrepancies between the two files, and since those two files are matching up to each other, the message log should show no discrepancies. And what happens is a blank window now opens with no discrepancies that show, because as I mentioned before, this specification was created based on the data file. And the data file and the message log that was created found no discrepancies. But unfortunately for South Coast, that isn't always going to be true. They're going to receive specifications from these companies that aren't going to be accurate to data files, or sometimes even the data files won't be accurate to specifications. So what they're going to need to do is they're going to need to know the different discrepancies that do show up. And since these situations do happen, we're going to try to simulate that kind of situation with this specification that we generated. So the first column in the specification we can modify is called unique. That box is not checked off. But if we check off unique, it's going to tell the program that the column we check it off in has to have the same, it cannot have the same value twice in that column that we check it off in. So we're going to check that off in column line number. The next column over is the nullable column, which is automatically checked off. But we can uncheck that, and if we uncheck that in a column, that's telling the program that any values in that column can't be null, meaning that there can't be any empty values in any fields in that column. The next column over is type. Type gives a general summary of what kind of contents are in the column that it's under. So for example, an in column number column, it's going to have all numbers in that column from knowledge of the file, I can tell you. So that detects it as an integer, meaning that there's only numbers. But we're going to change that to an alpha. If we change that to an alpha, we're telling the program that there can only be letters, which obviously isn't true for that column, so it's going to show us some errors later on. The next two columns are min length and max length. Min length and max length, as the name suggests, just tell the program that the values can't have any less or any more of whatever values are in those columns. So for the RP-RV number column, we're going to change that to from 14, because it's 14 for both values in actually the provider ID column, to 12. So we're telling the program there can only be 12 values instead of what was detected before be 14. We're going to skip the translation column for now, because translation is relevant to something later. It's not relevant to detecting the discrepancies within the message log. And the last column is the dependency column. Dependencies mean that the column that we're going to select the dependency for, which in this case is going to be the first name column, is dependent on the column we select with the next form that opens up, which in this case we're going to select last name. So we're saying that the first name column is dependent on the last name column, meaning that if a first name column value is found in the first name column, in that same row, a last name value has to exist. Which makes sense, because in most cases, if a first name exists, a last name should exist as well. So now that we've modified this specification that we generated based on the medical claims file, we're going to run a new message log. We're going to check for new discrepancies between this data file and the specification that we've changed. And since this data file is no longer accurate to the specification, it's going to find a lot of errors. The first error that shows up, for example, is telling the user that it expected the alpha value in the in-column number column, but it found values that were not alpha, which makes sense because that column had numbers instead of letters, which was expecting letters. So with this information, South Coast can either, if it's not a lot of errors, maybe make some modifications to the specifications or data files themselves. But if there's a lot of errors like this situation, South Coast is going to need to know at a later point so that they can contact the insurance provider or the file provider and tell them about all these errors. So maybe the insurance company can know that they might have sent the wrong specification or there was a lot of errors that they can really modify for future times. So with the last column that I mentioned in the specification that we didn't modify, which was the translation column, that column, as Alex explained in the presentation, was to find every single value that exists in a column and add it to a new table and to know how often that value occurs for every single instance. So what we're going to do for this case is the type SRBCD column, we're going to check that off, and we're going to generate a translation table on the type SRBCD column. And what's going to happen is, like I said, it's going to run through every single value in that column, and it's going to look for every unique case. And as you see with this translation table, there was about 15 different translation values that came up. And it tells you how many times they came up, and out of 4,998 values that were found in that column. So with values like the number 4, the letter E, the letter C, that doesn't really mean anything to someone who's just looking at that and doesn't know exactly what they're going to translate to off the top of their head. So that's why we create these translation tables to be saved to an SQL database, to be translated and saved into the database with it. A lot of times when the month-to-month data comes in and when they get new files, new translation tables, new translation values are found in the translation columns. So let's say 1 month from now, Alex at South Coast receives another medical claims file. He's going to want to start again by loading that into the application. And this file is very similar to the other medical claims file. And as you'll see very quickly with the preview form, that's going to contain the same predicted delimiter, the same amount of rows, columns, and the same headers. The difference is it has different contents. And they're going to need to know, specifically with the translation table, if there's new values in the type SRBCD column, which I actually modified this myself, the type SRBCD column in the medical claims new file, and I did add some new ones to show, for example, what happens when we check for new values. So what we can do is we can go into the translation button on the toolbar and select compare to data. And what's going to happen is it's going to take the translation table that we generated a moment ago, and it's going to compare the data file we just loaded in, and it's going to check every single value in that same type SRBCD column, in either column that might have been detected for the translation table on that translation table before, and it's going to look for new values. So as you can see, we get 3 new values: the letter Q, the semicolon, and the curly bracket. So now they know that the letter Q, the semicolon, and the curly bracket have not been found before in the medical claims file for the type SRBCD column. These are brand new to that instance. So what they're going to want to do now is they can take these values, save them off to the translation table that's in the database for the medical claims type SRBCD column, and they can go in and they can translate these new values so that they know what they mean. So for our application, that is all we have to demonstrate, and I would like to know if there's any questions.